Very well. So we're going to talk about confidence intervals for population mean. And then we're going to talk about population proportion and calculating the confidence interval for that. Very good. Here a little bit and follow the notes for you. Very good. Statistics, constructing CI or confidence interval for population parameters. Okay, so when you're talking about population parameters, it means that you either work with mu, the mean of the population proportion, or you're working with population standard deviation or variance. So our very first focus is working on population mean. When we are constructing confidence interval for population parameter, suppose you are working with population mean. Population mean is denoted by Greek letter mu. So let's use a different color, mu. Okay, very good. So what is the very first step in constructing population mean confidence interval? The very first step in building the confidence interval for population mean is to find the best point estimate. So step by step, we're going to write these down, go over the definition, and then go over a couple of examples. So step one. Step one, find the best point estimate. Point estimate for population mean. The best point estimate for population mean is the sample mean. It is sample mean. So the sample mean is denoted by X bar, as you remember. So again, let us go back to the question. We want to know what is the average math chem score in the Enzo College. Well, what you're going to do in the very first step, you're going to take a sample and you're going to find the sample mean. But one sample is not enough. Instead of keep repeating, taking multiple samples from that population and coming up with more sample means, we're going to build a confidence interval, an interval with all the values, all means that are in close by distance from the population mean. That's the interval. Very good. In the second step, step two, you're going to find something that you call the confidence level. Find the confidence level or CI. When we are talking about the confidence level, we are talking about the probability that the interval contains the population parameter. So the confidence level CI is the probability that the confidence interval or the interval contains the population, in this case, population mean or your mu. Okay, very good. So what are my options here? In statistics, when we're talking about confidence level, we either work with 90%, 95%, 99%. These are the actual popular confidence levels that will work in different projects. So the popular ones, C, or the confidence level is 90% or 95% or 99%. Guys, remember that sometimes the person or the company that gives you the project, they don't have any preference. They say, hey, we don't care about the confidence level. In that case, if it's not given to you, you're going to use 95%. So just a quick note. If C is not given, use C equals to 95%. Quick note for you. So again, what is our goal? Our goal is to construct an interval containing possible values close to population parameter, which in this case, population mean mu. So we have to follow some steps. These steps are very important. You need to follow these steps to make sure you have a correct confidence interval. In the very first step, you're going to find the best point estimate for what? For population mean or mu. In statistics, the best point estimate for population mean is sample mean. Population mean is denoted by mu. Sample mean is denoted by x bar. But just one value, it's not enough. It's not good in statistics. We need more values. Well, instead of taking more samples, we said that, hey, let us use something that we call the confidence level CI. What is confidence level? It is the probability that the interval that we're trying to build around mu actually contains mu. It's not too far away from mu. It actually contains the value that are very close to mu or population mean. Very good. So after finding the confidence level, what are you going to construct? You're going to construct the critical value. Okay, let us go to step 3. Step 3 is construct the critical value. So the critical value which we denote by Z sub C. Z sub C. Okay, constructing the critical value Z sub C. How do I find Z sub C? What's the step? Okay, so to find Z sub C, you have to use your calculator. Let's write this down. If C is your confidence level, 90%, 95%, 99%, remember the definition. It is the probability. Probability is the area, right? If C is given, what's the meaning of that? It means that you have the area below your normal distribution graph. Okay, very good. So C, or the confidence level. This is C. So suppose you have your C, the confidence level. Okay, this is this area. It might be 90%, 95%, 99%. It doesn't matter, whatever it is, this is just this area. What you're going to do, you're going to find ZC. ZC, the critical value, is the value that divides all the probable values from non-probable ones. So ZC is going to be here. How do I find ZC? Going back to chapter 5. So remember that when it comes to ZC, when you have the area to find ZC, you can find these little areas to the left and to the right. But what are those values? This area on the left and also on the right are equal to 100% minus C divided by 2. So we have 1 minus C divided by 2, which is this little area on the left-hand side. And also on the right-hand side, you have 1 minus C divided by 2. To find ZC, you can easily use your calculator. Very good. To find ZC, Z sub C, go to second, go to vars, and then go to inverse norm. Inverse norm, remember that? Last time we talked about the probability when we have the area, when we have the probability, you can easily find ZC by using inverse norm function in your calculator. So second, vars, inverse norm, and then you can find ZC. Use positive Z in your calculator. The area that you're going to enter is going to be 1 minus C divided by 2. Let me write it down here. Area is 1 minus C divided by 2. Since it's Z, mean is 0, and the standard deviation is 1. Okay, let's write down the instruction, then we're going to go over some examples so you feel comfortable about this. Step 1, take your sample, find the point estimate. Step 2, what is the confidence level? Step 3, construct the critical value Z sub C. And next, you need to find the margin of error. Step 4. Step 4, find the margin of error. Well, what is the margin of error? Margin of error is the largest distance between the population parameter and the point estimate that you have. The maximum distance between the population parameter, in this case, population mean and sample mean. Remember that one sample doesn't give you an accurate population parameter. When you're taking one sample, that sample statistic, in this case, sample mean, might be far away from your population mean. When you're constructing a confidence interval, you need to follow these steps and build the interval that contains all the possible, all the probable values close to population mean. So the margin of error, E, is Z sub C, the critical value that you found in step 3, times sigma divided by square root of n. Very good. Remember that sigma is the population standard deviation. So this is population standard deviation, and n is the sample size. Remember that you found Z sub C, this positive number, from step 3. This is a positive number. Okay, and the final step is constructing your confidence interval. So step 5, the confidence interval is equal to parenthesis. Well, here you have your X bar, the sample mean, minus the margin of error, comma, the sample mean, plus the margin of error. What is the interpretation? We say that, hey, we are 90% confident. We are 95% confident. We are 99% confident that the population mean is within these two numbers. So the last part, when you're generating your report to the boss, you're going to write a small interpretation. I am blank percent. It can be 90%, 95%, 99%, or other values. Confident that the population mean is in between what? X bar minus E and X bar plus this part is important. We are not 100% say that X bar is the same as the mean. We are saying that, hey, I am 90% confident, 95% confident, or 99% confident, depending on what is your confidence level, that the population mean, the guy that you try to estimate, one estimate is not enough. Guys, always remember that in statistics, we do not rely on just one sample. We need more information. We need more data, more values, more numerical characteristics around this guy. Okay, everybody. Let us ask group, let us ask group 4, a volunteer from group 4 to read the example for us. A volunteer from group 4, please read the example for us.
Is it the finding a point estimate?
It's correct.
Okay. Okay, and economics research is collecting data about grocery store employees in a country. The data listed below represents a random sample of the number of hours worked by 40 employees from several grocery stores in the county. Find a point estimate of the population mean?
Thank you very much. Okay, everybody. So you're a statistician. You are the researcher here. You collected the data, and these are the numbers that you want to use to estimate population mean. Okay, let's take a look at the board. Step 1, what is the point estimate for population mean? The point estimate for population mean is the sample mean. So what is your very first step? Your very first step is to calculate the sample mean. Very good. So what we found the sample mean. So this is our goal. This is in this example. Our goal is to find all possible hours that approximate the population mean hours. Okay, this is our goal, everybody. Okay, perfect. So what did we do in the very first step? Let's go back to our board, take a look at the board. In our very first step, we find the best point estimate. Okay. So what did we do? We just took a sample, right? In step 1, we took a sample. In step 1, we took one sample and we find the point estimate. The point estimate is X bar, the sample mean, which is 29.6 hours. Okay, very good. But it's not exactly the same as your population mean hours. What should I do? I need to go to next step, step 2. What is step 2? Step 2 says find the confidence level. If the confidence level is not given, we're going to use 95, we're going to use 95%. So step 2, step by step. Find the confidence level, which in this case, it's not given to us. So we're going to assume C is 95%. Remember that this number is not given to us. Since it's not given, we automatically use 95%. Okay, we're good so far. It wasn't that hard. Following the steps, step 1, step 2, step 3 requires a little bit of calculation. Take a look at step 3. In step 3, we're going to construct the critical value Z sub C using our calculator. Okay. So step 3. Step 3, find the critical value, which is denoted by Z sub C using calculator. So remember that use your calculator. Here you go. I have this calculator just right here. You're going to go to second, you're going to go to vars, and you're going to find the inverse norm. Why is that? Because the area is given to me. I just need to use inverse norm function to find the Z value. Find Z value. Okay. So let me go to second vars. And here, calculator. Let's turn on the calculator. Let's go to second worst, and then inverse norm, okay. So in the inverse norm, I have to enter something for the area, I have to enter something for the mean and the standard deviation. Take a look at the board. The area that you're going to enter is 1 minus c divided by 2, because the areas to the left, to the right of the graph are 1 minus c divided by 2. Okay, so I'm going to enter the area to be 1 minus c divided by 2, but c is 95%. So what do I have? I have 1 minus 95% or 0.95 divided by 2. So if I do the calculation, 100% minus 95% is just 5%, 0.05. Divided by 2, this area is going to be, well, 0.025. What is the mean? Mean is 0 with standard deviation 1. So the area is 0.025, mean is 0, standard deviation is 1. So let me do the calculation. It gives me a negative value, negative 1.96. If you round it to 2 decimal, you get negative 1.96. Take a look at the board. For the board, you're going to use the positive z value. Why is that? Because the z value helps us to calculate the margin of error. So the z value that you're going to use must be positive. So z sub c is positive 1.96. I found my zc. I'm good. Now I need to go to the next step and calculate the margin of error. Step 4. Calculate the margin of error. The maximum distance between the population mean and the sample mean, which is denoted by E equals to Z sub C times sigma divided by square root of N. Very good. ZC, I already calculate ZC, 1.96. What is sigma? What is N? For these two, we need to take a look at the question. What information are given to us about the population standard deviation and what is the sample size? Assume the population standard deviation is given to us as 7.9 hours. The sample size that you used was 40. Let's go back to the question, take a look at the question. Here, how many? 40 employees from several grocery stores. So N, or the sample size, is 40. And assume the population standard deviation is also given to you as 7.9 hours. Okay, let's enter these. 7.9 divided by square root of N, which is 40. If you do the calculation, the margin of error, the maximum distance between population mean and the sample mean is about 2.4 hours. We're done with step 1, we're done with step 2, we're done with step 3, we're done with step 4. Finally, the last step is, well, step 5, CI, the confidence interval, is open parenthesis, x bar minus e, comma, x bar plus e, and the interpretation is I am 90% confident, 95% confident, 99% confident that the population mean is in between x bar minus margin of error, and x bar plus margin of error. So my step 5, the last step is the confidence interval is open parenthesis x bar minus margin of error, comma, x bar plus margin of error. So the confidence interval is, what was x bar? Well, we calculated x bar or the sample mean at the beginning, 29.6 minus the margin of error, which is 2.4 hours, comma, x bar, which is 29.6 plus 2.4 hours. So what's the meaning of that? It means that the interval, including the population mean, is the interval starting at 27.2 hours and it stops at 32 hours. So if you remember the interval from algebra, here you have your interval. This is the interval that you have. Well, your sample mean is the central value. This is your center, x bar, which is 29.6. The lower limit of the interval is 27.2. So this is your interval. The lower limit of your interval, 27.2 hours. The upper limit of your interval is 32 hours. You can say that, hey, I am 95% confident that the mu is within these numbers. It might be like 30 hours, it might be 31 hours, it might be 31.9 hours, it might be 26 hours. We are 95% confident about that. I am 95% confident that the population mean is within 27.2 hours to 32 hours. Mu is population mean. Population, remember that. We do not have the population mean. That's why we took a sample, we found the mean of the sample, and then we used 95% level of confidence to construct this interval. It says, hey, we are 95% confident that that population mean, the mean hours, is within 27.2 hours and 32 hours. Well, now I expect you to ask, how do I use my calculator to make sure I have an accurate interval? My lower limit and my upper limit are both correct. So after doing the computation or the exam and the homework, you need to show step-by-step work. This is my step 1, then I go to step 2, then I go to step 3, then I go to step 4, then I go to step 5, and do the calculations, do the computations separately. You can use your calculator to make sure your final answer is correct. So let me put the calculator here for you. Let's turn on the calculator. So use your calculator. Well, it's not very hard. You're going to, so confidence interval using calculator. For those of you who are in computer science and who are using either Excel, I'm going to post the instruction and the codes for using Python. For now, for the class sake, everybody's using the calculator. So let's write down the instruction how to use the calculator. You need to go to stat. So go to stat and then go to tests. So let's click on stat and then the very first one is edit, use the arrow, not the calc, go to the tests. So stat, tests. Now you're going to go to Z interval. Guys, you are working with the confidence interval. You're going to find Z, you're finding ZC. That's why you're using Z interval. Remember that. Sigma is given to us. So we are finding Z. Go to Z interval. Z interval. Select Z interval. Okay. If you already entered all the data from your sample in L1, L2, L3, or either, select data. If not, click on stats. You already have all the information you need. Okay. Stats. So, well, what is sigma? Sigma population standard deviation 7.9. 7.9, so let's enter that. Then what is X bar? We calculated X bar. X bar is 29.6. 29.6. And then go to N. N, the sample size is 40. N is 40. Okay, here we go. And the confidence level, C level, the confidence level, remember that it wasn't given to us, so we automatically selected 95%. Guys, remember that, 0.95. It's a common mistake, the students forget to put the point. It must have 0.95. And then do the calculation. Very good. The confidence interval given to us is 27.2, 32. See how accurate the calculation on the calculator and the one that they did on the board match. So 27.2 and 32. So the confidence interval using the calculator is 27.2 hours, 32 hours. See, they are the same. So it means that the calculations that they did match the calculation that calculator did for us. So it means that we are happy, we have a great confidence interval. But as you can see, your calculator doesn't give you the margin of error. That's why you need to follow these steps on the exam, on the homework, on the quiz, and show step-by-step work that in step 1, I calculated X bar. In step 2, I know what the confidence level is. In step 3, finding the critical value. In step 4, computing the margin of error. And in the last step, finding the confidence interval.